We've seen examples of tunneling before. We saw how to tunnel IPv6 over IPv4, for example, where we have two parties that want to communicate over IPv6, but the path in between only supports IPv4. The solution in that case was to have nodes on the edge of the boundary between IPv6 and IPv4 that could cooperate and get messages through the IPv4 part. So an IPv packet that arrived at the entry node would get wrapped in an IPv4 packet, which is addressed to the other end of the tunnel, which would unwrap that packet and send it along. A second example we saw was virtual LANs tunneling over IP. So we have this situation where there are two different routers that we want to view as just links in a LAN, and we can do that by taking frames that are meant to travel over the LAN and wrapping it in a packet and routing that packet through the network layer to simulate a unified link layer. This is an example of tunneling a lower level protocol, frames at the link layer, through a higher level protocol, the network layer. So in general, tunneling can work with two things that are conceptually at the same layer or at different layers. All that matters is that there's cooperations on the two ends of the tunnel. We can use the tunneling idea to route packets and keep the source and destination confidential. We'll look at two examples that use tunneling to achieve that: a virtual private network and the associated protocol IPsec, which tunnels through IP, and Tor, which tunnels with onion routing through TCP.